4 is odds and expected values. So these are two different topics within the same section. Let me talk a little bit about odds. Have you heard the phrase odds before? Where have you heard it, Sarah? Races. You hear it a lot in races. I think in terms of horse races, for whatever reason, horse races is what I've heard even more. Has anybody else heard odds in relation to anything? Anybody else like that? In one of the games, yes, that's true. Yes, you do hear the odds. I mean, the odds always in your favor, right? So you hear odds in that sense, and odds are directly related to probability, okay? So let's take a look at how they're different. They're similar, but also how they're different then. So we're going to let P of A be the probability the event occurs, and P of A bar being the probability that it does not occur. Then the odds of the event happening are the probability that the event occurs divided by the probability that it does not. And it's equally true that you could also think of that as the number of ways that the event occurs divided by the number of ways that it does not, depending on the information you're given and the perspective you'll know it. You probably will do it. You won't even realize which one you're using at which time. They are actually two different situations. Now the probability, or sorry, the odds against the event A occurring is just taking the fraction and flipping it upside down. So this is the probability that it doesn't happen divided by the probability that it does, or the number of ways that it could not happen versus the number of ways that it does. So let me take a minute here with your Hunger Games example. So I saw the movie, still a little disturbed. But there was a point in the movie where they talk about when the young girl who was actually selected, she only had her name in there one time. And as they got older and were doing things and selecting, getting food and things, they get their name in the hat more times, right? So the more times their name's in the hat, the more chances they have of being this one on top. The odds are the probability that they're selected versus the probability that their name's not on the paper that's selected, okay? So that's what was going on in there. And we're going to do an example, okay? So from a set of 8 marbles, 5 red, 3 white, we pick one at random. Okay, so imagine you're in some kind of an opaque brown bag or whatever, so you reach in and grab the example. The probability that you choose a red, okay, so this is from last section. What is the probability that you choose a red? It's what? 5, because there's 5 reds, out of 8, because there's 8 marbles, right? So we write red on top of the total marbles, or total marble count, or something like that. Number of red over the number total, okay? Now, odds are done differently. When we do odds, OR, the odds of selecting a red, we actually write the number of ways we choose a red on top. So how many reds were there? 5. And we write that over the number of ways that we do not select a red, which would be 3, because there's 3 whites. Obviously, you can see that these are related, right? If I were to add the 5 and the 3 together, I'd get the 8 from the original fraction on part A's denominator. Yeah. And if I take the original fraction on part A and I subtract, I can get the 3 that's in the denominator here. And so there's a relationship between them clearly, but they're not the same thing. Okay, so here's an example of rain, because I talked about rain a little bit ago, right? If the probability of rain for the day is 60%, what are the odds against it raining? Okay. Well, the first thing I want us to take a look at is the probability of it raining. So this says the probability that it rains is 60%. And I don't know about you, but 60% is actually not a probability, right? How do I write that in terms of a probability? 60 out of 100. Can I reduce that? Sure. To what? 6/10 is a good start. And I can do one more time, I think. 3/5. Okay, so 3 out of 5. That's the probability. But we were talking about odds, right? So let's talk about the odds that it rains now. Now that's still not quite what I'm being asked for, but I'm going to get there. I just want to show you how to think about these 3 different things. So the odds that it rains, well, how do I do that? Well, I take the odds that it rains as 3 Sorry, let me write it out the way that we talked about it before. 3 out of 5 is the chance that it rains. What's the chance that it does not rain? 2 out of 5. So what happens when you divide 2/5 by 3/5? You know? You do get 3/2. So this is like 3/5. You multiply by the reciprocal, which is 5/2, right? The 5's cancel and you're left with 3 to 2. So the odds are 3 to 2 that it rains. So what are the odds against? Because that's what I was asked to find. What are the odds against it raining? 2 to 3. You flip up the fraction. That's all you do. The fraction just goes upside down. So if you've got one of them, you get the other one automatically. If you take a look down here at the theorem talks a little bit about that too. So this theorem here at the bottom says that the odds of the event are m to n, and this is another way to write odds, just like we talked about probabilities being able to be written like this, right? We can write them with or ratios rather, when we talked about ratios, being able to be written with a colon between them. So if the odds of the event are m to n, then the probability is m over m plus n, like my marbles example, right? 3 over 3 plus 2, 3 over 3 plus 5, which would be 3 out of 8, or 5 out of 8, depending on which one you're looking at. And then the odds against this would be the n, right, the number of ways that it doesn't happen, n, over the ways m plus n for that to be happening. Okay, let me do one more slide because it's still odds, and then we'll stop. All right, consider a 3-child family, like my family. What are the odds of having all of the same gender of children? So we could do a tree diagram, but we're not asked about these probabilities, we're asked about odds in this case. And when we did our tree diagrams for 2 children, as well as my 3 children tree diagram for the Huntington state at the bottom, what we noticed is that they all get the same value at the end, right? They were all 1/4, and then they were all 1.25, 1.8 at the end. So let's list out my choices, and we're going to list them in an organized way. I'm going to start with 3 boys. One possibility is I have boy, boy, boy. What's my next possibility? Boy, boy, girl. So I'd like to stick with as much staying the same to not lose any of the possibilities here. So I'm going to stick with the boy, boy. So I have boy, 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 or boy, boy, girl. Okay, that's all the ways I can have boy and boy at the beginning. The next possibility is then to have a boy, girl. Right? I could have a boy, girl, and then my next 2 options would either be a third one as a boy or a third one as a girl. Yeah. All right. And I think that's all my options of having a boy first, aren't there? I either have boy, boy, or boy, girl, and I've selected all those choices, so now I'm going to do the same thing with girls. I could have 3 girls, or I could have 2 girls and a boy last. Or I could have a girl first, and then what? A boy, and then another girl. Or a girl and a boy and a boy. So there's actually how many options? 8. There are 8 different arrangements I can have if I have 3 children in terms of their gender. Of course, none of this works if you have twins. We're just talking about, well, music sort of does, but more sequentially like that is how we kind of think about it. All right, what are the odds of having all of the same gender of children? Close. 2 out of something else. Yeah. So remember, so odds is the number of ways it happens. There's 2 ways to have all 3 of the same gender. And then this is the number of ways that it doesn't. There are 6 chances, 6 ways that I can have children and they aren't all the same gender. And we would reduce to 1 out of 3. So these are the odds of having all the same gender of children. So then, what are the odds against having all the same gender of children? 6 over 2, which would be 3 over 1. And we're not reducing it to 3 itself because we're talking about odds, so we need that ratio to stay present. It'd be 3 to 1. And if it bothers you to write a fraction like that, write it as a, the whole, which means that's like 3 over 1. Okay. 7 minutes. Do you want me to keep going, or do you want us a chance to do a little bit of group work? On this lesson, we won't finish this lesson regardless. The next section about this stuff is talking about expected value, so if we're both stopped, now is a good time.